Hey there, it's Mr. Cook, and we're going to go through the Unit 1 review for Algebra 2, one page at a time. So first page is going to focus on solving quadratic expressions. And when we solve quadratic expressions, remember that there are just a handful of things that we really need to master to be able to do this stuff. First off, we need to factor. We need to be able to factor. We also need to be able to use the quadratic formula. And we also need to know how to complete the square. Okay, so factoring is the first part of it. We have a factoring method that we've used in class a ton of times. The X method, where we want to look for two numbers that multiply together to be something and add together to be something else. Okay, so we need to understand what our factors are and all that kind of stuff. So have your factor sheets handy as I'm going through this stuff, and it'll help out a lot. Okay, starting off with the first one. So we need to find two numbers that multiply together to be the first number multiplying, so that's a 1x squared, so 1 times negative 12. 1 times negative 12 is negative 12. So we need to find numbers that multiply together to be negative 12 and add together to be the middle number. So now, even though it just looks like it has a plus x here, there's a hidden 1 that's always there. So that means that I'm looking for numbers that add together to be 1, multiply together to be negative 12. So the numbers that multiply together to be 12 are 1 and 12, 2 and 6, and then 3 and 4. If they multiply together to be a negative 12, then one of them has to be positive, one of them has to be negative. So since they add together to be 1, that's going to give you a positive 4 and a negative 3 that complete this whole thing. So when we factor, all we need to do is just keep in mind that we have a lead coefficient of 1, so we have 1x and then plus 4, and 1x minus 3 equals 0. And once it's factored, now you can just go into your solving algorithm for each of the factors. So if x plus 4 equals 0, that means that x has to be equal to negative 4, because we subtract 4 from both sides and we get negative 4. If x minus 3 equals 0, if we add 3 to both sides, we get that x is equal to a positive 3. These are our two answers that we need to find for the quadratic expression that we have here. Now, you can always check your work by taking the 3 for x and plugging it back into the x values that you see in the equation. If you plug in 3, you should get 0 for your answer. It's a handy way to make sure that you have the right answer. For number 2, again, do the same thing. You have your x's here, and then you take the number that's in front, 1, multiply it times the last number, c, so that's 1 times negative 15. So numbers that multiply together to be negative 15 and add together to be our middle number, which is negative 2. The numbers that multiply together to be 15 are 1 and 15, and then 3 and 5. So to turn it into adding a negative 2, we need to make that a negative 5 and a positive 3. Because these two numbers multiply together to be negative 15, a positive and a negative, and they add together to be a negative 2. Okay, so our variable is v, so we have 1 as its lead coefficient, so we do v minus 5 from the minus 5, and then also v plus 3 from the positive 3 equals 0, and now we solve. So v minus 5 equals 0. If we add 5 to both sides, we get v is equal to positive 5. That's one of our answers. And then if we have v plus 3 equals 0, if we subtract 3 from both sides, we get v is equal to negative 3. So these are our two answers. V is equal to 5 and v is equal to negative 3. Moving on to number 3. So for number 3, we have 1 for our lead coefficient in front of the n squared. So it's going to be 1 times negative 24. So we need to find numbers that multiply together to be negative 24 and add together to be the middle number, which is going to be a positive 5. So the numbers that multiply together to be 24 are 1 and 24, 2 and 12, and then also 3 and 8 and 4 and 6. So if we use 3 and 8, if we have a positive 8 and a negative 3, those two numbers multiply together to be negative 24 and add together to be a positive 5. So again, since our lead coefficient is 1, we have n plus 8 as one factor, and then the other factor is going to be n minus 3, and then that equals 0. And then when we solve it, all we have to do is just set each part equal to 0. So n plus 8 equals 0. If we subtract 8 from both sides, we get n is equal to negative 8. There's one of our answers. And then if we have n minus 3 equals 0, if we add 3 to both sides, we get n is also equal to positive 3. So that gives us both of our variable answers, which is going to be negative 8 and also positive 3. Moving on to number 4, so we need to find numbers that multiply together to be 16 and add together to be a positive 10. Those two numbers are going to be 8 and 2. Since there's only a 1 on the k value, then we're going to do k plus 8, and then k plus 2 equals 0. And then when we solve those out, we get k is equal to negative 8, and also k is equal to -2. So those are the two answers that we get for number 4. For number 5, notice that we don't have a c value there, so I can rewrite this as x squared minus 5x plus 0 equals 0. So I need to find two numbers that multiply together to be, let's see, 1 times 0 is 0. So they need to multiply together to be 0 and add together to be -5. Well, from numbers to multiply together to be 0, one of those numbers has to be 0. And then 0 plus -5 gives us -5. So those are our two numbers that we use. So x plus 0 is one of the factors. And then x minus 5 is our other factor. So when we solve it out, we get x is equal to 0 for one of our answers, and then x is equal to +5 for our other answer. So those are our two x values. All right, number 6. So there's no n value in between, so this becomes n squared plus 0n minus 64 equals 0. So I need to find numbers that multiply together to be -64 and add together to be 0. So the two numbers that multiply together to be -64 and add together to be 0, well, 64, its factors are 1 and 64, 2 and 32, 4 and 16, and then 8 and 8. So if we use -8 and +8, those multiply together to be -64 because one's positive, one's negative, and they add together to be 0. So to factor this out, I just use the 1 for my lead coefficient on n, so n minus 8, and then also n plus 8 equals 0. So if I solve each of these, I get n is equal to 8 for one answer, and then n is equal to -8 for the other one. So there's my answers for number 6. Number 7. So now we've had lead coefficients of 1 all the way up until number 7 and number 8, but actually we can keep the exact same solving algorithm for this. That's what we're going to start doing, is just multiply the first number and the last number together, just like what we've been doing secretly this whole time. So if I multiply 15 times 7, I get 105. So I need to find numbers that multiply together to be 105 and then add together to be a positive 38. All right, since we're dealing with larger numbers here, like 105, maybe building a factor tree is a helpful idea. So if we start with 105, the numbers that multiply together to be 105 are 1 and 105. That's a pretty obvious one. Another number that divides into 105 would be 5. So if I multiply that out by 5, I get 21. Now, if you're stuck and you can't think of other numbers that divide into 105, look at the numbers on the right-hand side or on the left-hand side, because if you can figure out numbers that divide into those numbers, they'll also divide into the larger number. So for example, 21, I know that's divisible by 3, so that means that 105 is also going to be divisible by 3. So if I divide it by 3, I get 35. And then I also know that 21 is divisible by 7, so if I divide 105 by 7, if I use my calculator, I'll end up with 15. So this looks like it's enough maybe to find our answer here. Let's see. So they need to multiply together to be a positive 105 and add together to be 38. That looks like 3 and 35 fit that description. Now, since I have a coefficient that's 15 in front of the x squared, that becomes part of the variable. Just like all of these have had 1 in front of them because it's had a 1 lead coefficient. This one has a 15, so it's going to become 15x plus 3. And then also 15x plus 35. Then the last step for factoring is that you got to divide out the common factor for everything. So 15 and 3 are both divisible by 3. So I divide out of 3 from both of these. If 15 divided by 3, I get 5, so 5x. 3 divided by 3 is 1, so plus 1. And then for the other one, 15 and 35 are both divisible by 5. So 15 divided by 5 is 3, so 3x. 35 divided by 5 is 7, so plus 7 equals 0. Now, just like what we've done before, we set each of these equations equal to 0 and solve. So if 5x plus 1 is equal to 0, then I subtract 1 from both sides, and I get 5x is equal to -1. And then if I divide by 5, I get one of my x values. X is going to be equal to -1 over 5. So there's one of my answers. Then the other one is 3x plus 7 is equal to 0. If I subtract 7, I get 3x is equal to -7. If I divide by 3, I get my answer. X is equal to -7 over 3. So those are my two x values for that, that quadratic that has a lead coefficient other than 1. So watch out for that one. Number 8. So same deal. We just take the first number and the last number. We multiply those together. 5 times -18 gives us a -90. So we need to find numbers that multiply together to be -90 and add together to be -9. So -90 is another kind of big number, so I'm going to use a factor tree for this one. So 90, if I do 1 times 90, and then there's also 2 times 45, and 3 times 30, 4 doesn't divide in, 5 does. So if I divide that by 5, I get 18. 6 and 15, not 7, not 8, 9, and 10. Okay, so that's all the numbers that multiply together to be 90. So if it's going to multiply together to be a negative, one has to be positive, one has to be negative, and if they add up to -9, the one that fits the bill is a positive 6 and a negative 15. So 6 and negative 15 go here, and then we just start factoring. So 5 goes on the A, so 5A plus 6, and then also 5A minus 15. Divide out the common factor. 5 and 6 don't have any common factors, so we just divide out 1. 5 and 15 are both divisible by 5, so we divide out 5. So this becomes 5A plus 6, and then 5 divided by 5 is 1, so 1A. 15 divided by 5 is 3, so minus 3 equals 0. Set each of the factors equal to 0 and solve. So if we have 5A plus 6 equals 0, subtract 6 from both sides. We get 5A is equal to -6, and then divide by 5, and you get your answer for one of them, -6/5. So there's one of my A values. And then the next one's pretty easy. A minus 3 equals 0. If I add 3 to both sides, I get A equals 3. So that's my other answer. So that completes the factoring part of it. I think I'm going to do this like piece by piece. So I'm going to start off with just factoring, and that's the first of the videos.